Okay, so thank you to everyone who's turned up for the webinar. We've got a great turnout, a lot of interest in the top 8 ways to speed up your SQL Server database. There are 3 of us involved today to present this webinar. My name is Marlon Marisha, the Sales Manager at SSW. But more importantly, we have Daniel and Mehmet. And Daniel and Mehmet are both solution architects at SSW. They have worked, for many, many years now with SQL Server databases, and they're also .NET programmers. And so the content today that will be presented is, a combination of experience and best practice and a whole heap of things. So what we want to do is present to you for about half an hour, 40 minutes. We'll see how it goes, the presentation, and go through these ways to speed up your SQL Server database. So Mehmet, without further ado, if you can take over this presentation, and let's see how we go.
Okay, great. Thanks, Marlon. Once again, thanks everyone for logging into the webinar. My name is Mehmet Ozdemir. As Marlon said, I'm a solution architect at SSW. I've been working with SQL Server since the version 6.5 days. Been involved in small and large projects involving SQL Server, Oracle, Teradata, mainly around BI implementations, and also the odd transactional system here and there. So the purpose of today's session is to give you guys some tips around SQL Server, performance improvements, how you can test and benchmark your code, how you can look at improvements you can make to disk, and looking at what the virtualization options are for SQL Server, because there does seem to be a bit of maybe still some myths around that area where people think, well, oh, should I virtualize, should I not virtualize? Just a quick point, if you have any questions while I'm going through the slides, feel free to send those questions in on the chat window, and we'll try to answer those as we go along. Any questions that we don't have answers for on the spot, we'll make every endeavour to get those answers back to you. So if there's something that we can't answer straight away and it needs a little bit more research, or we need to look something up, we'll definitely try to do that as well. So the agenda for today, first thing we're going to look at is some plugins that can make your life with SQL Server Management Studio a bit easier, some SQL tips, benchmark baselining, what are the disk options around SQL Server to improve performance, tempdb, that's always a performance hotspot, general settings for SQL Server, Hyper-V, SQL Profiler, and Perfmon. So with that, let's get started. So one of the things with SQL Server Management Studio, and I'm not sure how many of you guys remember back to the old Enterprise Manager days, but Enterprise Manager was quite sparse in terms of its capabilities, and then as we moved along to SQL Server 2005, 2008, and more recently R2, we got a fully blown Visual Studio interface to managing SQL Server. Now, the latest versions are actually quite good, but there's always some improvements that we can get from there. So we use a package called SSMS Toolpack, and it's freely available, and I'm sure there are other ones out there, both free and paid for, but the reason why we like using this tool is, well, one, it doesn't cost us anything, and two, it works reasonably well, and it does work as advertised. So the big, let me see if I can actually quickly bring up a browser window. One second. Right. So here's the full list of features, and I won't go through every single one. But there's quite a few improvements there. But the big things for us is the execution plan analyzer. So what we can do is when we're running queries and scripts, it's basically execution plan on steroids. So we get a lot more options. We get suggested improvements, and while the improvements are not, meant to replace a DBA, it's a good starting point, and it eliminates, you having to do all the work yourself, and it's great for programmers and programmers, coders who are not necessarily SQL experts. It gives them a good starting point for where they can improve their queries. So the other benefits of the Toolpack is you get SQL snippets out of the box. So, for example, if you look at the slide on the right-hand side, you can see that if you type in SSF and press enter, you automatically get the select star from, things like that. So you get shortcuts for updates, deletes, inserts, and various other statements. All that's customizable. The other really good thing that I've found, especially when I'm administering production systems, is window connection coloring. So what you can do is you can set up your servers, dev, test, prod, and you can set up dev window coloring with green, prod with red, and test with amber, or whatever color schemes you want. That way it gives you quick visual indication of what you're working on, and that you should be aware of what you're doing. CRUD statements. So while the SQL Management Studio will give you the generate statements for doing selects, updates, inserts, and deletes, the ones that come with SSMS Toolpack I find are a lot better, and they're customizable with templates as well, so you can have your own code in there. The other big one I like, but it's kind of it could be a dangerous option, is run scripts on multiple databases. So if you need to broadcast a script out to many databases, you have this option available to you as well. So with that, I'll try to grab this window in here and bring it in. So let me give you a quick rundown on some of the things that we get. So if you can all see my Management Studio window, you'll see that it doesn't really look much different. It looks pretty much the same, and all I've got in here is an extra menu item. But one thing that I really like is current window history. So you can see all the statements that I've typed in and a history of those. So I don't know how many times I've typed in a statement, run it, and then deleted it or changed it or done something, and I just want to revert back to the history. So I get that. The other thing that I do get to is when I run these queries, so if I run that, you can see that I've got my results set, my execution plan, and my client statistics. If I come to the execution plan, that's pretty much what you'll see in Management Studio now. But if I come in here and I do a show hide on my execution plan, these are the extra bits that I get with the Toolpack. Now, I'm not going to go through each one of these options, but the one I like is the suggested plan improvements. So the Toolpack will go through the execution plan and suggest improvements. So as I hover over there, you'll see here it's given me one suggestion, and if I come over the next one, it's given me another suggestion. So it's saying update statistics on this, check for indexes. So it's giving the coder and the DBA who's starting out a good place to look and a good place to get started in terms of making optimizations to code. And just a quick demo of those shortcuts. So you saw that SSF. These are all customizable, and these are very handy. Once you learn those shortcuts, you can be a lot more productive. So that was a quick tip on a plugin. Now let's go on to the next one. Now, filtered indexes. This is something new to recent versions of SQL Server. So we've had the ability to partition tables for a while now. So those of you that don't know about partition tables is where we can take a large table. So a really good example of that might be current transactions in an order processing system versus historical. So we might want to partition that table over multiple file groups, and we've been able to do that for a while. The new thing is filtered indexes. So essentially what we can do with an index now is if we have a big table of, say, I don't know, 100 million rows, that wouldn't be out of the ordinary for a big table, and we want all the historical data there, but we're really only interested in querying, the last financial year, or the last calendar year, or the last period, or whatever it is. But we still want that historical data in the table. We now have the option, so rather than creating an index over 100 million rows and having to put up with, creating statistics and updating statistics and, doing all this other stuff, or, the creation and the maintenance of the index. Now we can filter the index, and essentially it's just an index with a where clause. So if you know how to write a view with a where clause, or you know how to write a select statement with a where clause, then creating the index is not much harder. So let me grab my Management Studio up here. So if I go to, so this is just very quickly the AdventureWorks sample database that ships now instead of Northwind. So I'm looking at the human resources employee table. So you can see there's some indexes that are already there. For the sake of the demo, the employee table is probably not the ideal table to be running a filtered index on because it's not very large. But if I wanted to build a new index, whoops, that screen's gone off, so I'll bring that back in here. So, you'd be saying here index, my new index, whatever it is, you're adding your columns in, and really all you're doing is you're just adding the filter expression, and that's all there is to it. Now, the advantage of this is your index is going to be a lot smaller, they're going to be much faster, and you're just going to see, you're going to see benefits. And for us, there hasn't really been any downside to this, other than the odd occasion where you might be running a query where it's outside of that filtered index, and the index is not going to be doing the work for you there. But so be it. We seem to have missed our slide spot. Here we go. Okay. Now exists versus not in. This is something that I see all the time. So, and it generally comes up with guys who are not SQL DBAs or SQL programmers. So what they do is they write a query. So the bits around the green bit aren't that important. But what we have is we're selecting from a table. It's then what we're saying is where it is not in the lower portion of the screen that you see here. Now so let's compare that query to the next one. So what we say here is it's pretty much the same, but what we're saying is where not exists. Now the rest of the query is exactly the same except the middle bit is different. Now what we see when we do that is the encode, so the first one that I showed you, this one, the encode costs around 5 seconds. The exist code costs less than 1 second. So that is, it's more than a 5-fold improvement. It would be more like a 7 or 8-fold improvement if you actually got down to the to doing the benchmarking properly. The not exist is using an index and runs as one query. The not in runs as 2 queries, and a left join causes a huge table. So, just these little things make a big difference in terms of of performance. Now, how do you find these things out? Well, it's things that you learn over time, reading books, checking websites, stuff like that. But this is something that I see a lot, especially the in, and I say I've probably been guilty of it in the past, but not anymore. Okay, benchmarking. So what do we do when we're doing performance tuning? Generally, we'll run one query, and then we'll look at the client statistics or the execution plan or whatever. We establish a benchmark or a baseline, and then we think we've made improvements. Then we run it again and we go, oh, okay, that thing ran in 70% of the time, or it was twice as fast. But we don't realize that we've probably hit a buffer or a cache or something like that. So these two DBCC statements is a really good thing to be doing. So whenever we're doing benchmarking or baselining, we always run these two DBCC statements, drop clean buffers, and free proc cache. So one will clear all data from the cache, and the other one clears the stored procedure cache. So depending on what you're optimizing, it's a very good tip to make sure that you're actually comparing apples to apples, because you don't want to think that one thing is actually better than another when you might be hitting cache, or you're not actually comparing two queries against one another. So that's a really good thing to be doing. Disk performance. Now, this is getting on to a bit of the infrastructure side and the DBA side. SQL databases, I mean, I think it pretty much goes without saying that your SQL databases should always be on RAID volumes. Now, I'm quite surprised when I go into client sites and I see SQL servers that are installed on the C drive with the data and log files on the C drive with backups on the C drive, and these are, reasonably spec servers, yet whether it's a novice admin or maybe it's a virtual server, for the sake of expediency, it's just all been put on the one volume. Or, maybe not much better than that, you see the operating system installed on the system drive and SQL Server all dumped on the second volume, the D drive or the E drive or whatever it happens to be. Disk performance. So SQL Server is primarily all about I/O. So we need to be doing everything that we can to be increasing I/O performance. So RAID 10 is definitely where you want to be, and a lot of shops will just simply RAID 5. That's a big issue, because if you have a look at the graph below, you'll actually see that read performance of RAID 5 isn't too bad. Well, it's actually quite good. Not too far off RAID 10, but the write performance suffers a lot, because every time we write a bit of data over RAID 5 volume, we incur the overhead of the parity and all the other bits that are associated with writing the RAID 5 out. With RAID 10, we don't have that, because it's simply a mirror and a stripe. Sure, it costs us, it's a lot more expensive than RAID 5, but the performance is there. Now, another tip or another point that needs to be addressed are SANs. So beware of the SAN. The assumption shouldn't be, oh, we're running on this uber expensive SAN with 4 or 8 gig fiber connects back to our application servers, it'll all be right. You really need to be knowing underlying that connection, what are the disks on the other end, because the SANs can be configured with fiber disks, SATA disks, SAS disks with different speeds. They're now moving, some SAN vendors are moving to solid state disks. So, for example, a SAN equipped with a 7200 RPM SATA-based array will be vastly different to a 15K RPM SAS implementation. Also, on those back-end SANs, the SAN administrators might be under the covers giving you RAID 5 volumes instead of RAID 10 volumes, and you won't know that until you ask the questions. So that is quite important for optimizing your SQL disk performance. Following on from disk performance, tempdb. So tempdb should always be on its own dedicated physical disk. We need to give tempdb as much performance as possible. So the option there will be SSD-based storage or arrays, or very fast arrays. Now the second point here, and this one is one that's up for a bit of debate. A lot of Microsoft literature and a lot of stuff coming out of the SQL CAT team is one database file per CPU core. So what they're saying there is, for tempdb, we assign multiple files for every CPU core that we have. Now this isn't always correct, and there always seems to be an online debate as to whether you have a single tempdb or multiple tempdb files. That one I think is more of a suck it and see. In my own experience, it's only been on very high volume load machines where that's been an issue. So that one's up for debate, but it's worth including anyway. The minimum database size. So if your tempdb is doing a lot of work, then why not allocate the space up front for it? So tempdb might start off with 10 megabytes or 100 megabytes or whatever the standard is, and if you're doing a lot of work, and especially on analytical systems, then you're going to incur the hit for tempdb to auto grow. So the tempdb file will be growing by, say, 100 meg increments or gigabyte increments. Well, you'll have to wait for that file to grow for it to be available to you. So the recommendation there is, if you have a 100 gigabyte tempdb or a 200 gigabyte tempdb, set up front. It doesn't matter. It can sit there and be idle. Now, the next suggestion, and the following one is a bit interesting: disable auto update stats, and the next one is enable auto update stats. So which one's the right one? Well, it depends on your workload. So if you know that your tempdb and your workload are mainly small queries, short, sharp queries, then you may not want to incur the hit of the statistics. Or if you know that you are going to be in a heavily analytical system where you're dealing with very large sets, you might want to then enable statistics. So that is one where you'll need to look at your own workload and work out what the right decision is for you. But make a decision on it. Don't just leave it to the defaults. Monitor tempdb usage. So I've actually got some points here on that one that I had in my notes. So tempdb usage, we need to know what tempdb is doing over time, and there are some stored procedures and scripts that we can run to do that. And I've also included a link there. Marlon, we should be able to make these slides available to the rest of the guys, should they want that.
Yes, Mehmet. Yeah, I've sent a message.
Don't worry about having to sort of write that down. We'll send out the slides.
Yep, that's right.
So back to the monitoring tempdb usage, we can actually run. There is, like for example, db session space usage and db task space usage. So we can actually run some views and scripts to actually see that, and we'll send you out that information in the slides as well. Now, general settings. This one's coming up next. Now, with general settings, with SQL Server, a default installation of SQL Server will allocate all available memory onto, or make all available memory available to SQL Server. The general recommendation is to always have that setting set to the max memory minus something. So I generally like to look at a server and say, okay, that machine's got 16 gigs of RAM, and I like to start with 16 minus 1 and make 15 gigs available to SQL Server. That gives me a little bit of buffer on the operating system. Now, Generally speaking, SQL Server is good enough to hand the memory back to the operating system, but sometimes there is a delay. So if you want, so the idea there is to always have a pool of available memory for the operating system and for other tasks to use. You don't end up with waiting for SQL Server to hand that memory back. And as you profile that over time, you might find that you can get that down to 512 or 300, or you might need to increase it. But the 1 gig point is probably a good starting point to set that. Now, I'm sure most guys would know where that setting is, but most of those settings are all here in the server properties. So all those settings here. So for example, memory. Now, this is my own development machine, so it's just set to maximum anyway, but on a production server, you'd definitely be changing that thing. CPU affinity. Now, CPU affinity, that is where we can lock CPUs into SQL Server. I'm generally quite, and some people like to set this, some people say don't touch it. I'm generally quite cautious about this. I don't like changing CPU settings that much. So that's one that I will be looking at by exception only, and looking at the latest documentation from Microsoft on the affinity settings. Those settings will probably be going away in future versions anyway, so it's a good idea not to rely on them, because if they're not going to be there in future versions, then you're just creating a rod for your own back. OS data, logs, backups, they should always be on separate disks. So I would always advocate, the operating system, logs, data, backups. So, whether you want to call it C, D, E, F, or, whatever naming convention you have, always on separate spindles. And if you're in a SAN environment, this one gets a little bit tricky as well, because your SAN administrator might give you 4 LUNs, but you don't necessarily know where those LUNs have been sourced from. So they might all be off the same 6 disks or the same 8 disks in a disk group. So that's something that you'll need to work out with your SAN administrator and see if they have different levels. Like a good example would be backups, if you're in a SAN environment, would generally be on cheaper SATA arrays, and data and logs would be on your 15K disks, and maybe your OS disk might be somewhere in the middle. It all gets very interesting with SAN storage, because it's generally very expensive, and people or admins try to wring as much performance as they can out of them. No client tools on servers. That's why they're called client tools. So on a production server, we would never be installing Management Studio or any of the client tools. The reason for this is every time you run it, or every time an admin logs on with a remote desktop session and they run Management Studio, you're firing up a big fat binary that's going to sit in memory. If you want to do that, you run it on your machine and you connect in remotely. On dev boxes, sure, but on production systems, no client tools. You're just taking away unnecessary resource and memory from the server to do what it should be doing. Hyper-V. Now, a few years ago, if you asked the DBA whether they'd consider virtualizing an SQL server, the answer would probably have been unanimously no. That's changing now, but there's still a little bit of, I wouldn't say misunderstanding, but skepticism from DBAs as to being able to virtualize SQL boxes. There's no reason why you can't, and the performance is very similar. The caveat, though, is you can't expect to get similar performance to a physical box if you're virtualizing on a single server with, say, 4 cores with local disk that's virtualizing 15 guests. It's just not going to happen. So the requirements for fast I/O, good network connectivity, redundancy, all that other stuff that we expect from our servers doesn't go away just because it's virtualized. So we need to be speccing out our virtual guests just the same way as we do with our physical databases. And once we've done that, we'll see that the virtual performance isn't, it's negligible in terms of the hit. Now, The reasons not to virtualize, and this applies to Hyper-V, is if you need more than four vCPUs, so 4 virtual CPUs, or more than 64 gig of RAM. They're the current limitations. Now, Windows Server 8, or Windows 8 Server, whatever you want to call it, will go to 32 virtual CPUs and 512 megs of RAM. So that's substantially better. So in the next year or two, whenever it's released, we'll see enormous improvements on the Windows 8 side. For those of you guys that are running Windows 2008 R2, the R2 version of Hyper-V supports dynamic memory allocation, and SQL Server works fine with it. So we can over-allocate memory now. I think that feature's been in VMware for a while, but now we have it, and that was one of the really big things that drew me in to R2. So with R2, we now our virtual servers, I think, have 32 gigs of RAM, and we're probably allocated up around 48 gigs, and it works very nicely. The other thing with Hyper-V is make sure that the CPU priority level for the SQL virtual servers are higher than your other machines. So you want to give your SQL servers a bit more priority. Obviously, the obvious thing there is if all your machines have high priority, then there's no point. So some should be normal and some should be lower priority, obviously, so the priority levels can take effect. Preventing performance issues from occurring. Well, the first thing you can do is take a look at our rules page. We've got over 80 rules on our rules page on SQL Server. So it's not really, it is a bit of a plug for SSW, but they're all worthwhile and they're all worth looking at. Measure your uptime. So if we don't know how long our server's been up, how long our application's been up, then we don't have any basis to do any benchmarking or testing. Backup and restores. Now, I mean, sure, this is sort of not a preventive measure, but a catch-all or a just in case. We really should make sure that our backups and restores are set up and are running correctly and are running under the right maintenance plans. So a lot of shops that I go to, I see one maintenance plan that backs up all databases. That is definitely not appropriate. The maintenance plans for our backups should reflect the usage of the databases that we have on our server. So if we have a heavily transactional system, then we should have a mix of transactional backups and full backups, and maybe even incremental backups on whatever we think is appropriate. And then for our lightly used systems, we may just have weekly full backups. And for our systems that are used as part of ETL processes, they're basically throwaway databases, we may have no backups, and we just may save the schema out so we can recreate the skeleton of the database if we need to. Performance alerts. They've been in SQL Server for a long time. It's amazing how underused they are. So in the SQL agent, there will be a tab there that allows us to configure performance alerts, and so we can check, in terms of database sizes and CPU utilization and all sorts of stuff. Increase the log size of the event viewer. You'd be surprised how many logs will start getting generated with SQL Server. So it's a very good idea to increase that log file size so we can capture more logs without those files rolling over. And as I said on point 1, definitely take a look at our page, because there's a whole lot more than just this simple slide for you guys to have a look at. So when things start going wrong, what is the order that we check things in? Well, the first thing that we do is we check our hardware. Is everything running? Are there issues with memory? Are there physical issues with disk? Has one of our disks in our RAID array failed? Are our network adapters working right? All those things. Once they have the bill of health, we check at an operating system level. So we check our event logs, see if anything's fired there. Perform diagnostics at the operating system level. Then we'll look at the SQL Server itself. So by the server, I mean the server service and the application, so check the logs to make sure that that's all working correctly. And then finally, we check our tables, indexes, and our queries. Now, the checking of the tables, indexes, and queries, that will be a mix of checks that we use. So we will use a combination of SQL Profiler and Perfmon in Windows to be able to go through those things. So I'll cover that in a few slides' time. Now, one thing that we always do, and this is actually one of those rules, is whenever we create. So this is for the coders out there or for the developers. Whenever we create a connection string, we always tack in the application name. So, for example, here's my connection string. So, integrated connection, blah, 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 and then right at the end in red I've got application name equals bio tracker. So why do we do this? Well, the reason why we do it is when we use SQL Profiler to profile our app, we will always profile by the application name. Now, the reason why we like to profile by the application name is it's consistent. So we can if our application is targeting multiple databases, or if it's targeting multiple, for example, if we have a dev test staging schema or whatever we have, we know that when we target the application name, we only see the queries that are relevant to what we're looking at. So that thing, that little tip is, I think it's a really good one, and it's one that we use internally all the time. So Perfmon and SQL Profiler, this is where we really get into the nitty-gritty of doing our performance analysis, or seeing what's gone wrong. Actually, let me go back a slide. Okay, so these tools, I mean, there are plenty of other third-party tools available, but really these tools are built in, or one's built into the operating system, the other one comes with SQL Server, and they do the job, and they do the job quite well. The tips here is monitor from a remote machine, not on the server itself. And the reason why we do that is so we don't have the additional hit of these of Perfmon and SQL Profiler on the server. Now, another thing there is sometimes you won't be able to. Sometimes the box is so busy that getting a remote session up to run SQL Profiler, it's just not going to happen. So doing that from a remote machine is much easier. Save the logs. So when you're running Perfmon and Profiler, we should always save the logs. There's no point in running these things and not having the logs saved in a reusable format so we can analyze them later. So what options we have, we can log to the database directly, or we can log to a CSV file and import them later on into a database. And then once we have them in a database, we can then analyze that data. So we can see what's happening to that data, how those statistics are changing over time. We can analyze trends. We can say, oh, okay, this is when people started work because there was a massive spike. We saw it tail off at lunchtime, and then that's odd. There was this spike at 10 o'clock in the evening when we're not expecting it. Something's going on there, and that's causing other jobs that run early in the morning. It's having a knock-on effect because other jobs that are supposed to be running have failed. And we're only going to see that if we have this data in a reusable format and we can analyze what's actually going on. Perfmon and Profiler. So what are the things that we look for? I won't go through each one of these because we're running short of time, but the big ones, memory, disk, process, processes, and for SQL Server there's a whole bunch of settings that we can look at. The link that I've included below is an awesome video from a guy named Brent Ozar, and he basically goes through Perfmon and Profiler. You'll need to set aside an hour just for this video. I think it's 55 minutes long, but every minute of it is worth watching because he goes through from start to finish on using Profiler and Perfmon to diagnose faults and the fixes to those issues. So very worthwhile looking at that one. For Profiler. So references, so there's some references there, and with that we've probably come to the end of my presentations. I'll hand over to Marlon.
Okay, great. No, thanks, Mehmet. That was a great presentation. Thanks a lot for presenting that and preparing that topic.
Thank you.
Again, thanks for coming, and we'll speak to you guys soon. Bye.
Before you go, I've got a task for you. Go to tv.ssw.com and subscribe to our newsletter. You'll be informed of all upcoming videos. In addition, if you're super keen, I'm all about inspecting and adapting. So send me an email or send me a tweet @Adam Kogan. Cheers.